Welcome. In this lesson, we take an agent graph out of the notebook and turn it into a production-ready API. We'll cover wrapping it in FastAPI, persisting conversation state, streaming responses, containerizing with Docker, and scaling horizontally. An agent in a notebook is just a prototype. To serve real users, you need something reachable over the network that handles many concurrent requests, remembers conversations, streams output, and survives restarts. FastAPI is the standard Python choice because it's async native and gives you automatic documentation. Our architectural goal is stateless application replicas backed by shared persistent state. The service layer validates input with a Pydantic model, attaches a thread ID to the run configuration, and invokes the compiled graph. Use async invocation so a single worker can serve many requests concurrently while they wait on slow LLM calls. Always return a structured, validated response so clients have a stable contract. Each HTTP request is stateless, but conversations aren't. A checkpointer persists the graph state keyed by thread ID. In-memory checkpointers lose everything on restart and can't be shared between replicas, so production needs a shared backend like Postgres or Redis. The thread ID is your conversation key, and a shared store means any replica can resume any conversation. Users expect responses to appear token by token, not after a long pause. FastAPI's streaming response with server-sent events lets you yield chunks as the agent produces them. Use the async streaming method and emit each chunk as an SSE event, finishing with a done marker. Streaming dramatically improves perceived latency and lets clients cancel long runs early. Package the service in Docker for reproducible deploys. Start from a slim Python base, install dependencies, copy your code, and run Unicorn bound to all interfaces. In production, you typically run multiple worker processes or multiple containers behind a load balancer to use all CPU cores and add redundancy. Because state lives in the shared checkpointer, your application replicas stay stateless and you can scale out simply by adding more behind a load balancer. Never cache conversation state in a module-level dictionary or it breaks across replicas. Tune concurrency high since LLM calls are I/O bound, expose health and readiness endpoints for your orchestrator, and handle graceful shutdown so in-flight streams complete before a pod terminates. Finally, production agents need observability. Log request and thread identifiers, emit latency and token usage metrics, and trace each agent step. Multi-step agent failures are nearly impossible to debug without tracing. Keep all secrets and configuration in environment variables, never hard-coded, so the same image runs across environments. To recap, wrap your agent graph in async FastAPI endpoints, persist conversation state in a shared database checkpointer, stream responses with SSE, containerize with Docker, and scale stateless replicas behind a load balancer. Add health checks, tracing, and clean configuration, and you have a production-ready agent API. In the capstone, you'll apply all of this end-to-end.